Bismillahirrahmanirrahim. Assalamu alaikum. In the previous lecture, we discussed the basic definitions of physics. Now, in this lecture, we will discuss the mathematical form of physics as well as its applications and scope of physics. So, what is the mathematical form of physics and why we need to write a mathematical equation for the word physics? So, in physics, every topic can be expressed using a mathematical relation. For example, velocity is represented by this equation. Similarly, a mathematical expression is used for the acceleration, and for Newton's first law of motion we write as F external is equal to 0. So these all are the mathematical expressions which represents these topics. Now, it is necessary important to write an equation that represents the mathematical form of physics. And Einstein tried to derive that equation in 1905, which is called Einstein mass energy relation. Here in this equation, according to Einstein mass energy relation, energy is directly proportional to mass. That is, energy and mass are interconvertible. We can convert energy into mass and mass into energy using this equation. Now, to remove this proportionality sign, Einstein placed a constant here, which is c square. So, what is c and what is c square? C is the speed of light and its value is 310 power 8 meter per second square in vacuum. But c square is not the speed of light. It is the square of the speed of light called conversion factor. Here c square is called conversion factor. Its value is 9 into 10 power 16 meter square per second square. So a question arises that what is c? Why we write c for the speed of light? So C is basically the abbreviation of a Latin word celeratus. That Latin word means speed. Therefore, C represents the speed of light, which is constant in vacuum and changes with the medium. Now, what will be the application of this equation? How can we convert mass into energy and energy into mass? Practically, how energy is converted into mass and mass into energy. So, the applications of this mass energy relation, practical application is the fission reaction. In fission reaction, uh, a heavier radioactive element, for example, uranium, splits into lighter nuclei. So, if we measure the mass of the heavier nucleus, which is splitted into lighter daughter nuclei, and the mass of the product, that is the lighter nuclei, then there will be some mass deficit during this reaction. That mass deficit is that mass which is the deficiency is converted into energy, and that energy is called disintegration energy of the nuclear reaction. So we can find out the exact value of that mass by converting that energy using this equation. Similarly, another example is fusion reaction. In fusion reaction, uh, two lighter nuclei, for example, hydrogen nuclei combines to form a helium nucleus or a heavy nucleus. In this case, also some amount of mass is converted into energy, and if we calculate that energy mass from that energy, we can obtain the exact value of that mass. Another example is pair annihilation. In pair annihilation, an electron and its antiparticle positron recombines and forms two photons and emits two photons. That two photons move in opposite direction to maintain the law of conservation of energy, as well as their charges. Total charge here is also zero, and also photon have zero charge, so the charge is also constant. Now, in this case, the electron and positron are masses that converted into two photons, which is energy. Similarly, another example is pair production. In pair production, photons passes near a heavy nucleus and splits into two particles. One is electron and the other one is its antiparticle, which is called positron. So here photon is just energy, and that converts into electron and positron in the presence of a heavy nucleus, a nucleus, and that is mass. Therefore, in this case, energy is converted into mass, and in this case, mass is converted into energy. There are many other examples of this equation. For example, a very poor example of this equation is photosynthesis as well as the combustion of wood. Now, what will be the scope of physics? Why we need to study physics? So, the scope of physics is very wide. It ranges from very tenuous subatomic particles, that is electron, to the huge galaxies. We can study the properties of electron using physics as well as to study the properties of huge galaxies, to know about galaxies. So also another scope of physics is we can find out very minutest time interval, that is up to femtoseconds, between two events using physics up to the age of universe. Similarly, the non-living objects, from non-living objects to biophysics and many more. Thank you for watching this video. In the next video we will discuss the physical quantities.